Welcome to the first part of Yale Service Training's two-part program on lift truck battery maintenance. Today we'll look at the single component most often overlooked by experienced service technicians who troubleshoot and repair electric lift trucks, the battery. Sure, it's easy to take batteries for granted. As long as they're working properly, you don't give them a second thought. And if a battery does go dead, most people figure you simply recharge or replace it. So what's to know about batteries? A lot. Many service technicians don't understand that the battery is the single most expensive replaceable item on an electric lift truck. And a lot of service technicians don't completely understand the relationship between lift truck performance, component failures, and the battery. Properly used and cared for, a lift truck battery can have a working life of over 5 years. But at the same time, batteries are the #1 contributing factor in all problems affecting electric lift trucks. That's right. The majority of problems service technicians find on electric lift trucks can be traced straight to the battery. This includes failures to the directional and pump contactors, hydraulic and traction motors, SCR panels, and all related components. Over the years, just imagine how many otherwise experienced service technicians have misdiagnosed the real problem and replaced parts without understanding that their problem was actually caused by a faulty battery. In many cases, a knowledgeable service technician can correct battery problems or eliminate them altogether, reducing costs, downtime, and customer dissatisfaction. So after completing this two-part program, you'll know to troubleshoot the battery first before you troubleshoot any other electric lift truck component. You'll understand batteries, what's inside them, how they work, and how they're rated. That's what this training program is all about. In order to get the most from this series, though, it's important that you already know some basic electrical concepts. If you're not completely familiar with these concepts, you should brush up on them before continuing this course. They're all covered in Yale's battery textbook, STL 1534. Ready to see what makes a lift truck battery work? Good. Let's move on out to our service area. Today we'll join George Woodring, an experienced Yale lift truck service technician. Hi, George.
Hi. You're right, I am experienced, but most of my experience has been with gas trucks.
That's not unusual, George. A lot of service technicians receive most of their training on gas trucks. But I'll bet, like most technicians, you're seeing a lot of electrics in your shop.
You're right. More companies are using electrics every day.
Do you know where to begin troubleshooting an electrical problem on an electric lift truck?
Well, no, I'm not really sure.
Where would you start looking if a gas truck won't start?
Oh, that's easy. I'd make sure it isn't out of gas.
Well, George, if you have a problem with an electric lift truck, you should check its source of power first, the battery. Oh, by the way, we'll do our best to cover everything in the time we have today, but if you don't understand something, you should check Yale's Industrial Lift Truck Battery Textbook, STL 1534. We'll be referring to it frequently as we work today, and you should do the same. If you don't have one, just contact Yale. They'll be happy to get one for you. Okay, let's get started. To begin with, lift trucks use a lead-acid battery. Its chemical reaction process generates electricity. Battery size is carefully selected for each lift truck model by the truck manufacturer. So never put a battery in a lift truck that's smaller than the battery specified on the capacity plate. Don't think that a battery is a battery. An undersized battery will result in poor lift truck performance, premature component failure, electrical problems, and can affect the safe operation of a lift truck. Battery weight is an important part of the capacity rating because it affects the weight distribution of the lift truck. It's important to keep enough weight on the trail axle to counterbalance the rated load and to keep the trail wheels on the ground while traveling or steering. If you find a truck operating with a battery different from the one indicated on its capacity plate, contact the manufacturer before putting that truck back into operation. And never switch batteries between trucks without first checking their capacity plates. Let's go over here. Lift truck batteries are rechargeable. You'll be using a charger like this one. Recharging is easy, but you have to know how to do it safely. This battery looks like it's in good shape. There are no leaks, missing vent caps, or corrosion. Before working on a battery, always make sure to follow basic safety procedures. Wear eye protection. Wear rubber gloves. And always unplug a battery before checking or troubleshooting it. Always make sure you remove your jewelry. Because jewelry is a good conductor of electricity, you could get a severe burn. And never smoke around a battery, because battery gases are explosive. A battery is made up of many different compartments that are called cells. These cells are connected in series to form a single battery. Each cell has a voltage of approximately 2 volts. Voltages for lift truck batteries are normally 12, 24, 36, or 48 volts, depending upon truck type and model. So a 12-volt battery has 6 cells. A 24-volt battery has 12 cells, and so on.
What's inside a cell?
Inside each cell are a number of parallel plates arranged in alternating order. Positive, then negative, then positive, and so on. A highly porous non-conductive material separates the plates. All positive plates are electrically connected together in series, and the negative plates are also connected to each other in series. The plates sit in a liquid called an electrolyte, a mixture of sulfuric acid and water. Acid is highly corrosive. That's why we wear the rubber gloves and use eye protection. There are different types of electrolytes for different types of batteries. We'll discuss electrolytes in more detail in part 2 of this training program.
I understand how the cells are connected, but how does that create electricity?
It's through a chemical reaction process. But I'll show you. When electrolyte is added to the battery cells through filler caps, the chemical reaction of the electrolyte creates a positive charge on the positive plates and a negative charge on the negative plates. This creates a potential difference, measured in volts. A support placed between the plates and the bottom of the battery prevents short circuits which could be caused by sediment buildup. Never use tap water in a battery. It contains minerals that will accelerate sediment buildup. Understand what I mean?
Sure.
Good. The entire assembly is housed in a high-impact insulated case.
How is the battery connected to the truck?
By terminals like this one, called posts.
Oh, just like the posts on my car battery.
That's right. Lift truck batteries have a positive terminal and a negative terminal.
Okay. I think I understand the parts of the battery, but what is the battery rating?
Each type of battery has its own battery rating, also called battery capacity. It's the amount of usable electrical energy stored in the battery. This rating is listed in terms of amp hours. Batteries are usually rated for a 6-hour discharge cycle. So a lift truck performing common operations should be able to operate for about 6 hours before we need to recharge its battery. For example, a 600 amp hour battery can deliver 100 amps for 6 hours. However, to ensure maximum battery life, the recommended usable capacity is generally 80% of the rated capacity.
And how do I know when a battery is discharging?
Whenever a lift truck battery delivers current to any circuit, it's discharging some power. Certain functions, such as lift, may drain considerably more power than others.
Well, how do I measure how much a battery is discharged?
You can measure it 2 ways. First, you can measure battery voltage. As a battery discharges, voltage decreases. You can measure the voltage of each battery cell using a multimeter like this one. We'll learn how to use a multimeter in part 2 of this training series. Most electric trucks measure battery discharge electronically using a standard gauge called a battery discharge indicator. It works like the gas gauge on a gas truck. However, measuring the specific gravity of a cell with a hydrometer is the most accurate measure of battery discharge. The specific gravity of a cell is the ratio of the weight of the sulfuric acid and water mixture in a cell to an equal amount of pure water at a specified temperature. Pure water has a specific gravity of 1.0. In a fully charged cell, the electrolyte normally has a specific gravity of 1.275 to 1.285. We'll learn how to measure specific gravity with a hydrometer in part 2 of this training series. Well, that about covers the basics of lift truck batteries. As you can see, there's a lot to learn. But learning it now can save you time and effort later on the service floor.
You bet. And when things really get tough, I've got this to refer to.
You're right, George. Thanks for helping us out.
My pleasure.
We at Yale Service Training hope you found this introductory video on lift truck batteries informative and helpful. If this information is new to you, we recommend watching this program several times until you're sure you're familiar with all the information. And refer to your Yale Service Training Battery textbook, STL 1534, often, whenever you have questions. When you're comfortable with the information in this introductory video, you're ready to move on to the second video in this series, called Industrial Battery Troubleshooting, which will make you a lift truck battery troubleshooting expert in no time. Until then, thanks for joining us. We'll see you again soon. Welcome to part 2 of Yale Service Training's two-part program on lift truck battery maintenance. Today we'll learn how to troubleshoot batteries using a hydrometer, a shunt meter, and a volt-ohm meter. We'll show you how to properly locate and correct common battery problems using a basic 5-step procedure. First, we'll demonstrate the visual inspection. Second, the cell voltage test, followed by the battery current leakage test, the specific gravity test, and finally the battery load test. These procedures are also described on Yale's STL 1535 Battery Troubleshooting Guide. After viewing part 1 of our program, you already have a basic understanding of lift truck batteries. So let's get started troubleshooting batteries. Joining us again is George Woodring, the Yale lift truck service technician who helped out in the introductory part of our program. Did that program help you, George?
You bet. I know a lot more about lift truck batteries now than before the introductory program.
Good. For example?
Well, to start with, I know they're the most expensive single replaceable item and the #1 contributing factor to all electrical problems with electric lift trucks. So that's why I always troubleshoot the battery first, before any other electric components, like the solid-state electric controls, the motor, or the contactors.
That's a good start. But now we'll learn how to locate and correct battery problems as quickly as possible by developing good troubleshooting skills. Let's get started, George.
Not so fast. Another thing I learned is that before we begin work around a battery, we have to follow a few basic safety procedures first. Unplug the battery, wear eye protection and rubber gloves. Always remove your jewelry. And don't smoke around a battery. Battery gases are explosive.
You really did learn a lot last time, George. And one more thing before we start. Don't forget Yale's STL 1534 Industrial Lift Truck Battery Textbook and the STL 1535 Troubleshooting Guide, which will help you through the correct troubleshooting procedures.
Yeah, you're right. They do help a lot.
We'll be referring to this material as we work, and you should do the same. Let's start troubleshooting. You always begin with the visual inspection of the battery. You look for maintenance neglect or physical abuse. By inspecting a battery on a regular basis, we can correct many simple problems quickly and easily and prevent other problems altogether. Best of all, inspection takes only a few minutes. Normally, we would do the visual inspection with the battery in the truck, but we've taken it out so that it's easier to see here. And here's how you do it. First, check for missing or broken vent caps. They're important because they prevent dirt from contaminating the electrolyte. They also prevent electrolyte from spilling, which can cause electrical shorts and corrosion to the truck's frame. Next, check the cables and battery connectors to ensure they're in good physical condition. Replace them if necessary. Next, look for any signs of corrosion, dirt accumulation, or wet areas caused by electrolytes spilling across the top or sides of the battery. This contributes to battery current leakage, which we'll cover in more detail later. For now, when you find any of these conditions, you need to wash the battery before continuing. Before you wash a battery, always remove it from the truck. Never wash a battery while it's still in the truck. Water is a good conductor of electricity and could cause electrical shorts to the truck's wiring and components. Now prepare a mixture of baking soda and water and scrub the battery terminals with this solution using a soft bristle brush. When you've removed all the corrosion, rinse and dry, either with an air hose or by letting them air dry. That's all there is to washing a battery. Our final visual inspection is to check the electrolyte level and color in each cell of the battery. If the level is low, add distilled water, never tap water, and recharge the battery. The color of the electrolyte should be clear. If the electrolyte is dark, replace the battery and contact the battery vendor. Oh, and here's an important tip. Whenever you get a replacement battery, always inspect it. Never assume that it's in good condition.
Well, this battery looks like it's in good shape to me.
Our next troubleshooting procedure is the cell voltage test, where we check the voltage of each cell with our volt-ohm meter. This test helps locate any cells with low voltage, which will affect the battery's performance. First, ensure that your volt-ohm meter is operating properly, and calibrate it according to the manufacturer's operator's manual, like this one. This enlargement of a volt-ohm meter will help you see the various scales. Set your meter to the lowest possible DC scale, in this case, the 2.5 volt scale. Read the voltage across each cell by placing the positive lead of the meter to the positive terminal and the negative lead to the negative terminal. We've added letters N and P here to help identify the terminals. The open circuit voltage should be about 2.1 volts per cell. Repeat this process for each of the cells and compare the readings. If there is a difference of 0.05 volts or more between any of the cells, there's a problem.
Well, I got readings of 2.1 volts in all the cells except for this one, which reads 1.7 volts. So I guess there's a problem.
When we find a difference in voltages that large, it may be necessary to recharge or even replace the battery. That depends on the results of our next two troubleshooting procedures, the battery current leakage test and the specific gravity test. The current leakage test determines the amount of current leaking from the battery case to the truck frame. Current leakage of more than 100 milliamps is considered excessive and could interrupt normal circuit operations and destroy electrical components, such as the solid-state logic card. That's why it's so important to begin all electrical troubleshooting operations with the battery.
What causes current leakage?
Current leakage can result from a dirty, corrosive battery, which creates an electrical circuit between the negative and positive cell terminals, using the frame of the truck and the case of the battery to complete an electrical circuit. In severe cases, current leakage can result from a shorted cell to the battery case, which can occur if a cell jar is broken. To begin the current leakage test, set your volt-ohm meter to the 500 milliamp scale. We need to first get readings from the positive terminal to the truck's frame, like this. Then repeat this procedure from the negative terminal to the frame. In both cases, we're looking for readings less than 100 milliamps.
Well, from the positive terminal to the frame, I got a reading of 75 milliamps. From the negative terminal to the frame, I got, let's see, 170 milliamps.
The reading from the positive terminal to the frame is okay. It's less than 100 milliamps. But the reading from the negative terminal to the frame is more than 100 milliamps, which could indicate a shorted condition. We already washed our battery, so we know our current leakage problem is not the result of dirt accumulation or corrosion. The problem cell should be the one with the low voltage reading that we identified earlier. To confirm this, set the volt-ohm meter to the next voltage scale that is higher than the battery's voltage. For example, if you're working on a 36-volt battery, use the 50-volt scale. Now we're going to check the voltage from the negative terminal to the frame, because we already identified that the leakage is on the positive side. It may be necessary to use a lower voltage scale in order to get a more accurate reading. Okay, The voltage reading on this 36-volt battery is 24 volts. We call that positive volts because the negative meter lead is on the negative battery terminal and the positive lead is on the frame. Divide the voltage reading you get by 2 because each cell is worth 2 volts. That gives you a good indication of which cell of the battery is leaking. Our reading was 24 volts. When we divide that by 2, we get 12. The problem is with the 12th cell on the positive side.
That's the same cell that gave us a reading of 1.7 volts earlier.
We've just confirmed that this is our problem cell.
Well, I can understand that. But what if a battery isn't excessively leaking or shorted?
Well, that's easy. We're ready for the next test, the specific gravity test. The specific gravity of a cell is simply the ratio of electrolyte to water at a given temperature. Measuring each cell's specific gravity is the best way to check the battery's condition.
To measure specific gravity, use the hydrometer, right?
That's right, and it's pretty easy. Use the hydrometer to draw electrolyte from a battery cell, holding the hydrometer like that straight up and down to get the most accurate reading. It's important to measure specific gravity only after a battery has been fully recharged and allowed to cool down. Temperature affects the specific gravity of the electrolyte, so you have to measure the electrolyte temperature after measuring the specific gravity. For each 10 degrees above 77 degrees that the electrolyte reads, you add 0.003 to the hydrometer reading. For example, let's say our hydrometer reading is 1.260 and the temperature is 92 degrees. We subtract 77 from our temperature, 92 degrees, multiply that by 0.003 and divide by 10. Rounding to the third decimal place gives us 0.004, which we add to our original reading to get the true reading. For each 10 degrees below 77 degrees that the electrolyte reads, you subtract 0.003 from the hydrometer reading. For example, let's say our hydrometer reading is still 1.260, but our temperature is 45 degrees. We subtract the temperature, 45 degrees from 77, multiply that by 0.003 and divide by 10. This gives us 0.010 rounded to the third decimal place, which we subtract from our original reading to get the true reading. Compare the true reading you get to the specific gravity number listed on the battery's nameplate. It's located either on the first cell strap of the positive battery post or on the side of the battery. If this information cannot be found on the battery, contact the battery distributor. If the reading varies less than 10 points, the battery is in good condition. If there is a difference of 10 points or more, you have to adjust the cell's specific gravity by either raising or lowering its value to meet the listed number. For example, if a cell's specific gravity is too low, we need to raise it by adding 1.400 electrolyte, which is the recommended electrolyte number for lift truck batteries. Never use an electrolyte with a specific gravity reading higher than 1.400. The acid concentration is too high and it will shorten the life of the battery. If a cell's specific gravity reading is too high, we need to lower it by adding distilled water. In either case, whether you're adding electrolyte or distilled water, add only a few ounces at a time. In either case, always recharge the battery for an hour and a half before retesting. In many cases, adjusting the specific gravity of a cell will restore most of the original amp-hour rating, depending on the battery's age. After correcting the specific gravity of a cell, you move on to the final test, the load test. This test shows us how well the positive and negative plates of each cell react under a loaded condition. For this test, the battery must be in the truck. We use a shunt amp meter to measure current draw. Place the shunt amp meter in series with the battery. Cycle through the hoist lifting circuit several times to remove battery surface charge. Put the mast in the lowered position and make sure the power steering motor is running. Running the power steering motor will provide a 20 amp load, which must be maintained during testing. Check the voltage drop across each cell using the volt-ohm meter on the 2.5 volt scale. there should be less than 0.05 voltage difference between each cell. If the difference is less than 0.05 volts for each cell, the battery is in good condition. If the difference is greater than 0.05 volts, recheck the electrolyte level and the specific gravity reading. If the electrolyte is okay, replace the battery. After performing this 5-step procedure, the visual inspection, the cell voltage test, the current leakage test, the specific gravity test, and the battery load test, run the truck. If it still isn't running properly, the battery isn't causing the problem. So you can begin to troubleshoot other components. Using the troubleshooting procedures we've covered today, you should be able to find and correct most battery problems you're likely to run into. Be sure to set up a preventive maintenance schedule for your batteries, using a daily checklist like this one for each battery. By visually inspecting and properly maintaining your batteries on a regular basis, you're sure they're always in good condition, preventing many problems from occurring in the first place. Thanks for helping us out today, George.
Anytime.
We at Yale Service Training hope you found this program on battery troubleshooting informative and useful. We recommend you watch this program several times until you're sure you're familiar with all the information. And remember, proper troubleshooting reduces costs, so it really pays off.